everything.
Good morning. Yes, we can hear you. Did you want me to share from your screen or you want me to respond from here?
I think if I will share my screen, it will be more efficient, so nobody will be overloaded with task to change the slides. So I hope it will be more convenient.
Okay, I'll go ahead and give an introduction. So I happened upon this next presenter by just doing some Google research and trying to figure out a good way, because in the past we have kind of talked about handheld devices, being able to scan things, analyze things in the field, and looking at different apps that we potentially could use. And then started watching YouTube videos, and you know how those rabbit holes go. And then happened upon our next presenter, Dr. Maryna Kuzmenko. She is CEO and founder of Petiole Pro, an agri-tech platform that transforms smartphone and drone imagery into AI-powered crop insights. She has led 3 grants funded by the governments of the UK and the EU, with platforms cited with over 110 research papers, and hopefully more to come. And hopefully you guys can utilize this application. And she will present on the applied AI for soybean breeders, tools, workflow, use cases.
Thank you so much. I would like to ask you to allow me to share my screen if it's possible, and then we will start.
Did you request?
Yeah, I sent. Sharing is not turned on. The host isn't allowing sharing for this meeting. Unfortunately, I see this as of now. I try to do my best again, but not yet. One more time. Still some issues.
Open up.
I think something, yeah, magic happens. Yes, I see. I see I can share. So good. My question to you, can you see my screen? I will do it now full screen, so we will not be limited with some.
Yes, we can see your screen now.
Okay, good. So thank you so much, Brian, and thank you so much for your team for opportunity to speak today. And I've been with you yesterday and today. I suggest my format of presentation will be slightly different than you already had. At the same time, yesterday you spoke a little bit about technologies, about machinery. So I would like to support this direction and bring some technological but different angle, how you can do your research and your work more efficiently. So we will build our today presentation, explain the points which I declared before. However, I have 30-something slides, but I will try to keep everything consistent. So my main goal is here, first of all, to explain you what is the difference between AI and applied AI. Maybe some of you already know, but also we will try not just to name the tools which exist for soy breeding and for work with soybean production, but also we will try to understand in which specific workflows these tools can be applicable and scalable, because obviously you can do something with one, let's say, leaf or one pod, but if you have 1,000, then it's a different question, and today we try to answer it. First of all, regarding our company, thank you so much, Brian, for introduction. We are the UK-based company. We exist for already 9 years, and we have some nice journey so far. At the same time, it's not just a general journey, because we have something more specific related to the soybeans. And our flagship mobile application, which is called Petiole Pro, we developed it. It's free mobile application. We developed it a few years ago, and since then we got some good coverage by the scientists who are using our mobile application specifically for leaf area measurement. And speaking about soybeans, we have 3 research papers which are directly referencing to our mobile application as the data collection tool for within the specific soybean experiments, but we will focus on them a little bit later as well. So as I promised, let's start with the point number one, the difference between AI and applied AI. Why I am writing about applied AI. So what is AI for soybeans? Just ask any search engine, any AI chatbot, and you will get the answer. But this answer is kind of like summarization plus dreaming plus ideation, because again, we are not speaking now about the strongest and weakest points of any AI system, but in general, there are so many directions where AI can help in soy breeding. But the problem is that some of these directions, they are quite far in terms of applicability. And if you ask any AI chatbot, how can I use existing tools for my soy breed research, then you get the answer that there are this and that and like 10, at least maybe 5 or 10 directions how you can use AI. But if you will try to use that in fact, it will be not so optimistic, and you will have 1, maximum 2 real working cases. So that's why we are not speaking about general, all purposes, all directional AI for soybean breeding. We are speaking about something which is practical and applicable. And this is just a visualization how it looks like. It's all about the real, because again, my topic, I decided to make it a little bit overall overview, because going in more specific, it should sound like applied visual, probably smartphone based AI for soybean, because this is how we what we do for the last 9 years, and what I see the biggest promise for practical application. Because I understand you all work in science, and there are today we will discuss this as well, but thinking about this your work on research as well as extension part, it's important to understand not just opportunities which rely in front of very expensive equipment, very expensive cameras, but also what we have having just an ordinary smartphone in our hands, what we can do. So, and yes, this is the real photos from Kansas University a few years ago. We did some nice help to one of the researchers, but I will highlight it as well later on. Let's start with the, so we already understood what is the difference between AI and applied AI. So regarding the tools, basically all the tools which I will mention today, they are based on main core technological stack, and it's called machine learning or deep learning, which is actually the part of machine learning. So let's call it machine learning and computer vision. Computer vision, it's kind of like technological eyes, how the computer can see and understand what's on the imagery. And machine learning is helping us to not just have this data, what's on the imagery, but process it and find the patterns which exist in this imagery which has been collected. Additionally, we will also mention today the remote sensing. In our case, we are speaking about indexes. So probably you already heard and discussed NDVI. It's the most popular when you need to understand the deficiency in crops. And this is one of the methods. Again, we will speak about that. And sensors mentioned already, I've heard, and in my case, it will be just an additional, very nice to have point, how you can have a few layers of data to support your suggestion, which you have in your research or in your production, when you need to monitor environment and understand how its impact on specific stage. But again, on the left-hand side, you can see you already know these stages so much and better than me. But I mean that we will focus on each specific stage, and depending on the stage, we will see which tools can be applicable and for what tasks. So let's go with the first one, which is germination count. And not germination count, but it's germination, but the first initial task which we can do with AI in this stage, it's about counting the seeds which has been germinated. And for these tasks, we actually use the ordinary RGB camera, or it's a smartphone camera, it's RGB camera. So that's why we don't need any extra supportive tool for doing these tasks. As well as based on this information, we can get not just number of germinated and non-germinated cells, but also we can count the germination rate, which can be helpful, and it can be done automatically. At the same time, yes, and here, as you see, the bonus which I mentioned is about the using additional metrics, which you can understand how the environmental changes can impact the germination rate, and again, depending where you are growing, where your trays are placed, you can diversify your experiment conditions. And if we speak about automation of this process, here you can see the example which we have done, and but the only thing, it's not soybeans, and but our goal, and again, my goal today is demonstrate you opportunities. So sometimes imagery which I will show you, it's not straightforward about soybeans, but they are in parallel with what can be done for soybeans. So in this case, we have the seedlings of trees, and the main beauty of this automatic calculation is that the person is not standing in front of these trays and counting everything by eyes and by fingers and then writing into the notepad. It's all counted automatically, and it speeds up the process of germination assessment. And again, it's a digital proof of the status of the specific experiment which they had. At the same time, as I mentioned, it's not soybeans, and we tried to use the same algorithm for the imagery which is here, because on the right hand side you can see real soybeans. It's one of the people who using PTO, he shared with us and asked, can I apply your module for the soybean germination count? And we said, you can try, obviously, but the challenge is here. You can compare and already visually see the difference. And this is the, and even a human can see the difference. Obviously, the computer, I mean computer vision algorithm, it also sees the difference, and it's lost. It doesn't understand what we want from it. That's why the challenge for counting germination seeds, germinated seeds in a current situation, is to provide the relevant data for training, adjusting the model, because it's already existing. So we just need, so the model already knows that there are cells and there are probably some seedlings inside, or no seedlings. If no seedlings, then it's not germinated. So it's already existing. But in all AI models, the problem is to bring the relevant data, train the model, and then the performance and the accuracy can be improved and boosted. Yes, so this is one of the opportunities which we have on the germination stage. The second thing is about the counting, which we have already on earlier stage. And here I must say that it's very interesting opportunity introduced by one of the researchers, because as you can see, the possibilities to use smartphone for just taking photos. You can use obviously drone for again RGB drone, or RGB camera on the drone, or it can be a different yes, it can be a different camera, for example, multispectral one. At the same time, as I mentioned, for low-cost experiments, one of the researchers, he was using the selfie stick, and he added the smartphone, which was looking below and exactly on the plants. So this was kind of like innovation and not innovation, because it's kind of nothing new, but it was very interesting application of how the imagery can be collected, and it was scalable because he was just walking along the row and he recorded the video of the seedlings which were emerged, and based on this video it was possible to process it and count them. What is else important here? Also we can count not just presence of seedlings, but also on the later stage it's possible to assess the gaps between them, and this can be again one of the metrics which can be demonstrated as the result of a specific experiment. And one more point is about environmental impact. So again, it's possible to link the data about germination and the count with the existing, if you have any weather condition data, it's possible to link it and again to build the dependency. And another thing which is important is that on this stage it's possible to get the bigger trends and understanding some kind of diseases or presence of chlorosis, let's say. But what we discovered that on later stage, when the leaf growth is present and when there are a few leaves at least, it's much more productive to introduce wider scope of tracking some specific characteristics or trying to measure them. And here is where I would like to get a little bit more details. For example, here, as I mentioned, we can use the RGB cameras, so ordinary cameras which is available, and they're collecting ordinary photos, but also we can use multispectral cameras which help with early stage detection of diseases. And and nice to have, I mentioned satellite imagery, but the challenge of satellite imagery, again, it will be discussed in one of the slides, that it's not as accurate as we wish to have specifically for soybeans. But I want to focus on multispectral imagery. Just, I hope you already know and seen it, but if not, because for me it was quite a discovery on earlier stage of our work, because most of the time I worked with RGB, which is on the left hand side. At the same time, multispectral, why it's possible to discover the disease of plant using multispectral, because it's actually provides extra waves. So you can see how the same leaves of, again, it's apples, as I remember, apple tree, they look through multispectral imagery, through multispectral lens. But at the same time, it should not be mixed with another very similar looking, you can see probably it in vertical farming settings, this purple light imagery, because as you see, it's absolutely different, and the processing of this imagery is different, because if you are capturing the image in LED light, you are processing it as the RGB imagery. So you are processing it other way. You cannot get the early disease detection in these conditions. But with multispectral, it's possible. And now I just think, what if we will use multispectral in LED light? Maybe it's a new interesting point what to check, but I mean that at least you will see this visual difference and you will know the next one. Yes, so as I mentioned, on this stage, when we already have leaves, we can do a lot. And the first thing, which is again based on smartphone assessment and existing technologies, is about leaf area measurement. And here we have our research papers which are citing our mobile application. So basically they are, it's standard procedure, it's nothing new that we just bring in the digitalization element in the task of manual, what is done manually currently in many cases. So we bring the accuracy to this work. And as again, for some experiments, it's also about scalability, because for manual assessment, the limit of time and human capabilities, like you can spend 1 day of having the leaf area measurement using either ImageJ or grid paper. But with our case, with our mobile application, you can take, in some cases, we have researchers who have taken thousands of photos, because they have a big selection of plants and they need to measure all of them. And again, the big data in this case brings better accuracy of their results. So, and they're just taking photos in front of the calibrating plates. So we have calibrating plates. This is calibrating plate, and the leaf can be placed on it or next to it. And yeah, I have, as Brian mentioned, I have like a huge assets of videos how to measure leaf area using our mobile application. But I mean that this is how the experiment, when you are applying any agricultural input, or when you are trying to assess the success of, maybe not success, but impact of the environmental change to your specific variety. So there are thousands or maybe millions of scenarios where the leaf area can be helpful parameter for your experiment. And this is one of the methods how you can automate. Oh yeah, sorry, I even forgot that I have extra visualization of how it works. So this is the screenshots of our mobile application. And also, again, as you can see, I demonstrated you the big calibration plate, but in fact we have also, because of the different requests from different growers, we also developed this one and this one, and the smallest one on the right hand side we developed specifically for the researcher from Colombia who was measuring the leaf area in her natural conditions, where in the Andes, in mountains. Yes, because our mobile application, it works without internet, so you can use it offline and then yeah, just access it. And it works again. We have our Petiole Pro mobile application and also our new Petiole Spruce mobile application. I will show it later on. But let's just move from leaf area now to a different task, which is also interesting, about early stage detection of some changes which happen in plant. Again, this is cucumbers. This is not soybean. But the concept is that having proper imagery of proper quality, it's possible to do the early stage diagnostics of chlorosis. And in this case, we had the farmer who had 6 lines of plants, and he was interested because he applied different treatments for each row. But obviously he had this thousand of, not thousand probably, but quite a lot of plants, but I mean at least leaves were 4,000 to count, but probably it's around less than 1,000 plants. But still, visually he said us, I see that these are greener, these are not so green, but how can I prove this status that this is green and this is not? And that's why we had a threshold of greenness, and based on this threshold we built the model, which were firstly it was, as you can see, the first was video, then the second was the segmentation of each leaf which was collected by him from the video, and then it was a comparison of each leaf based on this threshold which we had. And the farmer was absolutely happy because before he didn't have any numbers, and then he got this. Obviously, I put just the brightest, the most important numbers, because we provided him 6 pages of different metrics, how it can be compared with each other, with overall, with average, like, you know, different opportunities, because it's not so difficult to extract, having good data and process it. Another interesting opportunity which exists is about the disease pressure assessment. And again, this is apple tree leaf, and one of the grants which we got in our history, it was from the UK government. We were developing the AI system for early stage detection and monitoring of apple scab and apple canker for the UK farmers. And our idea was to help to bring the tool which can support the understanding of disease dynamics. Because as you already seen, leaf area is okay, we can count it. But how about the small lesions of problems of the scab? So basically our task was, first of all, to detect them, because on early stage it's quite difficult to see them. And the second stage was to measure them. And based on this measurement, again, we have the threshold when the disease is, let's say, it's always dangerous, but sometimes it's less dangerous or more dangerous. And also it's about the continuous monitoring. Because specifically for apples, there is a preventive spraying as a regular procedure in orchards. So on each stage, it's possible to monitor before and after and see the trend where the disease is moving, and is it declining or not declining. And as you can see, we are not just demonstrating in pure units, I mean not in square centimeters, because what we discovered, the farmers, they don't have time to understand, is 24 centimeters, it's big or small. They love percentage, and we try to deliver the most useful information for them to show the result, the impact on the specific sampling which they are doing. Another point about pests. And we worked with soft fruits and other fruits. They are counting pests in sticky yellow traps. But as I understand, the most challenging for soybeans is a little bit different experience. And again, here we have some parallel with measurements of the area which has been damaged, so which I demonstrated here for the diseases. And the same method is applicable. We are still, I hope we will release this case study soon. It's currently in our pipeline, but it's possible again to quantify the damage which is on the leaf and see the progress. And the same situation with the lower part. And I think I have some even, yes, because we already worked with some cases when the leaf has been eaten by some specific pests. So it's possible to not just to count the area which left after this procedure, after this eating, but also one of the possible use cases is to calculate which area has been eaten, and it's bring the percentage to understand again the impact. And here is one of the just examples of our what we have been working with. Again, it's about the damage. Then I also see that flowering is one of the very important stages, because it's all about yield, and it's not only in soybeans but also here you can see I added strawberry flower count as an example of possibility. At the same time, I understand that for flower count is very important because it's about yield prediction. And this first stage, when you can just get some numbers, yes, you obviously know about the variety and you have some expectations, but then you need to go in field and get the real data, real field data. Here I mentioned the methodology which can be used for this task, and it seems that handheld tools like smartphones are the most relevant. But again, if you have a huge field, you can do just sampling, and based on sampling and applying statistics methods, you can scope the account, because as we were speaking about the nitrogen deficiency and building the remote sensing, using the remote sensing for building the maps and indexes, with flowers it's a different story. Drones, they cannot capture properly the flowers because they are hidden. Flowers are hidden below the leaf coverage. And also there is one more point, quite technical, but just for your understanding, that if the soybean have, let's say, purple flowers, at least it's kind of difference. But if they are white or somewhat yellowish, then it's a difficult point for computer vision algorithm, even with good labeling. Labeling, I mean, when you are on photo, saying to computer, so this is the flower, this is the leaf, you are label them, and then the algorithm can work with this data and recognize what is what. But I mean that when they are very similar in color, and especially captured with drone, which is flying above, so there is some distance, so probably there is some blur, because it's always when the drone is moving, either you need to have the slower speed as well as lower distance, but then there are so many flowers which are hidden below the top leaves. So it's not actually either commercial viable or practically viable to use the unmanned aerial vehicle for counting flowers, and it's more practical what we see to use the handheld devices to collect imagery, or it could be even the type of camera, or even you can attach smartphone to quadricycle or any tractor and collect the existing data, but on the level of plants, and it's not above, it's more insightful than you are doing it from top. And also, yes, again, I mentioned about phenology models, which can be helpful to predict the flowering window, but it's a little bit more in depth, which you need to do some research and get this data and try to fix every pieces of this puzzle into proper order. So that's why I just try to demonstrate to you here that the first stage is possible to use the computer vision to get this raw numbers of flowers, and then based on this you can even add on top anything and get even richer outcome. But again, the main thing to get this count. Then we have another the same challenge here with pod. Pod fill is again, the color is the same. The challenge is just to see them below the leaves. So again, we see the effectiveness of in-field phenotyping in comparison when we are doing remote sensing phenotyping. And again, we are demonstrated here on the right-hand side. Chili peppers, it's not the beans, but still the shape a little bit similar, and sometimes the chili peppers are also, depending on the variety, they are green. So it's possible to do the counting of chili peppers, as we have discovered in Kenya. This is the raw imagery from Kenya, which we have collected during one of our grants, which we were actually looking for the pest which hidden inside the chili pepper. But to discover this pest, you need to collect the data about all chili peppers existing in this specific greenhouse. So that's why we didn't, it was not the main goal, but it's in parallel how we got the count. It's because we need to do another task. And I forgot about, even on earlier stage, about the thermal imagery. Yes. So it's one of the interesting directions which you can discover, specifically if you are looking for water stress detection. And water stress detection can be done on earlier stage when we spoke about the leaf, when the first leaves appear. Starting from that stage, you can use thermal cameras on drones to detect the specific areas of interest when you see some problems, let's say. And later on, with drones, you cannot count the pods and the flowers, but you can detect the stress, specifically water stress, and this method is applicable for other crops as well. And yes, and if there is a need for any late season foliar disease assessment, again, it's possible to use either with drone or handheld devices like smartphone, but again, with drone for this task, it's more scalable. Then approximately the same, I will not repeat it one more time, but because actually the difference, as you know, it's about the changes of color and harvest readiness. So again, it's possible to do this computer vision classification. Are they ripe or not? Are they ready to harvest or not? And based on this sampling, you can build the expectation calendar when to harvest the soybeans. And now we go to the next stage, because before we spoke about the pre-harvest, we spoke about the in-field or in greenhouse when we are talking about the germination. Here we speak about the post-harvest. And with post-harvest, there are just two directions which you can apply to automate your post-harvest assessment of seeds. First one is visual assessment, and basically we are doing this. And it's one of the, let's say, successful stories, because visual QA is possible, automatic. It's in pretty controlled environment, so you are not dependent on temperature or anything. You have just the same setup of light and data collection protocol, and based on this you can do assessment of seeds in terms of first of all its count, then about size. I think I can, yes, oh no, later on, sorry. So we can do the presence or absence of any defects, as well as any visual crackings or any problems which exist on the sample. Additionally, if you need the deeper analysis, then there is another way. It's not a separate way, it can be added to on top of each other, but it's more expensive way, let's say. It's about the hyperspectral imagery, and again, it's about near-infrared imagery and X-ray, which are given the information about internal situation with every seed, because computer vision and deep learning and all RGB imagery, they are good in assessment what we see, what's going on here visually, but it doesn't speak about any chemical profile of the seeds or any internal problems of the seeds. With other extra stock, you can get the full understanding, and again, the proteins, oils, it's possible to discover, but the price of the equipment is pretty expensive. And in production level, we see the automated QC machines and sorters based again on computer vision and the performance. And then now I want just to summarize the workflows, and maybe on top of this, we will see the more practical examples as well. So first of all, as I mentioned, satellite imagery. Why I am not speaking about that at all? Because it's not quite accurate for the purposes of I believe the most of plant breeders, they are interested in very specific results of the experiments and moving on the experiments. But the satellite imagery, it's more, let's say, for policy, for understanding the overall scope of the production. And as you can see, I discovered one of the interesting screenshots which compare the results, the imagery collected with drone on the left hand side, and the two imageries. Next one is the different resolution of 5 meters and 10 meters, and it just it doesn't give proper insights which are needed. The next thing, as we mentioned, drones are quite good, excited and successful, and obviously this is the tool which can help you to collect data in wider scale. And as you can see on the right hand side, this is the gaps which I already mentioned before. And specifically, drones are very good for count, for understanding the lodging, because, for example, with handheld devices, it's not so visible, but you just need to go up, and then you see the areas of challenge with lodging on the later stage. And again, about maturity, about the color difference, they are good. And finally, regarding mobile devices, about mobile application. So as I mentioned, we can work with germination, then we can do the in-field scouting and all these levels which are already mentioned. Plus, as I mentioned, we do the operational excellence. Because what we discovered during these years of work with breeders and growers, that to get the number is not just the task. You always need to add something like related to this number. Either it should be the variety of what soybean you are growing, or when you have sowing it, when you have applied any fertilizer or any type of agricultural input. So it's always not a story of one number, but a journey of growing. And it has to be added smoothly. And what we have seen that, for example, we have done the counting and that's it. It disappeared because it's already the next stage. So our goal is to show this continuous way. And the final stage is post-harvest. I already showed it. And this is on the right-hand side. You can also see the screen from our QC of soybeans. And now just a few demonstrations of how our PTO Spruce mobile application work. As I mentioned, we see the journey of growing, not just the application of computer vision and deep learning to get this number. So one of the main tasks, one of the pains which we have heard is that we have a grower who has these 3 experiments, and then he has 4 applications of fertilizers, and then he was doing this Excel table and trying to put results over there. But again, his work was in the field, and then he came to office. He tried to transfer his notes from the field to this Excel, and it was quite time consuming. So that's why we created this capture on the go, and you can see the 3 the final result is the image which has fields which you need to have for your report, for example. And then next day or next week you come back and you are taking the image of the same plant and you fill the same fields, so you can see the progress of how everything changes. And as a result, you can see the historical change, not just they are somewhere in Google Drive and then you need to go and think, okay, where can I find it? The same situation here with quality. As I mentioned, on the left-hand side, it's already existing web application, so you can try it. The middle side, it's PTO Pro, and the right-hand side, it's about this journey of continuous addition of some extra attributes, information which you need to add. Again, if you have the multiple calculations during the day, you can, at the end of the day, have a summary of this work. So it's not just about doing one job to be done, but to making it like in a result of something. And just a little bit reminder, on the left-hand side, we are doing not just counting and showing what we have counted. We also show the allocation. So we do standard deviation, and then we show how many of the seeds are in the average area, in the smallest, in the biggest, so you can see how they are, how they vary. Additional, as I mentioned, operational excellence. Again, one more pain, one more pain which we heard from people, because again, you know, we were worked just with plants and with seeds and all the stuff, but the growers, they're just telling the reality, and they told that all this information which is saved in office, and sometimes they are lost, sometimes under the rain, and the nodes are not very good. So our mobile application currently allows to add all the operation which you have done specifically. For example, for the same experiment, you are doing irrigation, you can add the same information for this experiment number 1, let's say, or you have the soil test results. Again, it's important to have it maybe at the end of the experiment in 2 years or whatever you will have this experiment, but you don't want to lose everything. Obviously, you have that on the laptop, but again, we are going to the stage when you can having all data in one place, then you can feed it into AI algorithm, which can provide you more insights, because sometimes we are missing something, but AI can help us to summarize data, and you already know how they are good in terms of this. And the same with crop protection applications, because it's very easy to be mixed up with how many have I applied, how what have been applied, and it's possible to get this digital proof of some specific operation. One of the research papers which we have in PTO Pro was about actually the measured leaf area, but the task for them was to assess the application, or the just give me a second, how to say, setting up the nozzle on the sprayer, and they wanted to understand the output which they got. So basically they were using the water sensitive paper, and then they trying to assess the footprint of this each nozzle and each setting. And this is the interesting point, because PTO actually can help with this as well. And it's not agricultural directly application for breeders, but I understand that, moreover, I saw the yesterday's sessions as well, that applying different type of agricultural chemicals is an important job. So if you need to assess the nozzle print output, then it's possible to quantify it as well, not just to have the visual assessment and get some percentage at least. And I think it's something already the end, because this is the core ideas which we have now in our agenda, that first of all, we want to have the mobile application and mobile device as the center of data collection for the grower of soybeans, and it's possible to have it, and there are the results of this. It's not just you have digital receipts of your actions. You can get the trends, you can get the dashboard as well. But also it's possible to get the AI on demand. As I demonstrated at the beginning, the challenge with germination count was that the model was not trained for specific data. But it's possible to train. So for example, if we have already developed something, we can go in depth based on your imagery, and we can build it together, and it will be help for your productivity. And yes, we also have the not just mobile based application, but also the Windows based application, which is a little bit, let's say, production side, because what we see that in most cases the data collectors, people in field scouts, they go with mobile applications. But for managerial work, for understanding the overall situation, the managers are sitting in front of the screens of desktop. So that's why we have the application for desktop as well. And final bit of science. So it's not straightforward about the soybeans, but as I mentioned, maybe it will be helpful for you. We also do the automatic count of stomata, and this task was brought to us by wheat breeders. So they were trying to assess their success. And but again, the manual count was quite challenging. So currently we have a web application, and we have also mobile application. So we will be more than happy to share it with you. And another success story, as I mentioned, from Kansas University is about nodal count. And this is specifically for soybeans, because I remember the researcher contacted me and he was like asking me, you are measuring leaves, but I am working with roots and we need to count these nodules and they like take my day off. I am busy with other tasks. So can you help me? So we decided it's interesting task, and it happened like 3 probably years ago. So when before the AI boom, so computer vision was not like so popular application, but we see obvious growth now and interest. And this is the result of the count. So yes, and this is almost pre-final. I also do some educational work. So on Udemy, there is a course called AI in Agriculture, practical basic course. So if you are interested in all this, maybe what is machine learning and what is the difference between machine learning, deep learning, and also maybe what is the difference between traditional farming and smart farming, like, something which we have heard a lot, but sometimes we just need to remind ourselves about the basics, because currently AI movement is quite fast. In agriculture, it's not so fast because of the seasons and because our long cycle of which are line on biological cycles. So it's not the same, like, for example, in other industries. But still, in this course, I try to explain the basics. So I will be glad if it will help you. And if you want to stay in touch, I am on LinkedIn and I'm on YouTube. And also on LinkedIn, I have the newsletter called AI in Agriculture. And I already published a few specifically focused newsletters for soybeans. So hopefully they will be interesting for you as well. And yes, our mobile application is available on Android. It's already available on Play Store. So just go there, download it and use it. And ask me questions if you have any. Thank you so much.
From the room? All right, thank you for joining us. Thank you, everyone. That will conclude the talks for this part of the day. We'll have a coffee break here. If you do come up with any questions, feel free. I can give you Maryna's contact information. You can email those questions. Just play around with the app. See, and I'm sure that if you have any special project that you're looking at, that maybe she can work on training models and moving forward with the AI.